Just a minute. Do you see my screen? Hello? Do you see my screen?
Yes, I'm not seeing your presentation.
Is now okay?
Yeah, thank you. You can go ahead. Now your presentation is visible.
Okay. Um, Thank you, and good afternoon once more. The topic of my talk is NTLab's ATK PPP GNSS receivers. NTLab is, first of all, I would provide just some facts about the history of my company. NTLab is a privately owned, vertically integrated center of design and production, founded in 1989. We produce ASICs, modules, and systems for various applications, and also we produce IP components and chips, also related to GNSS applications. This slide includes just a photo of some of our products. These are OEM boards, integrated devices that include inertial sensors inside. Also, here the receiver for that can play a role of the reference station is presented. So it is assembled a device that includes GNSS board inside, which is capable of tracking of all current GNSS signals. Also, it is our intention to propose co-development, licensing, and joint manufacturing in accordance with Make in India concept. We are looking for cooperation, and we offer navigation equipment for high precision multi-system multi-band GNSS receivers with PPP and ATK capabilities. So we are focused on high precision GNSS applications. This slide includes our customers in India. We work with ISRO and other organizations and companies. Also, it is very important for us to establish good contacts with universities in India. We cooperate with University of Burdwan, Jain, Marwadi, and the National Institute of Technology. This slide includes information about our dealers in India. And here we will talk about our products. First of all, I would like to mention about RF frontends, which are specifically designed for supporting NavIC signals. So these are multi-channel RF front-end ASICs NT1062, 1066, and 1068. All of them support NavIC signals, including S-band system. Um, in order to compute position, of course, it is required to process samples which are generated by these RF frontends. So it is a transformation from um, uh, analytical to digital signals. Also, it is our digital signal processing chip that which is capable of supporting many GNSS systems and signals. So this 1058 chip is capable of supporting NavIC, GPS, GLONASS, Galileo, Beidou, satellite systems with various frequency bands. Also, we contribute to the designing the antennas with SAW filters. This filter was specially designed for supporting NavIC L5 and S-band signals, and it was designed in cooperation with Qualcomm. It is just a general information about our GNSS, about our OEM GNSS boards. All of them are multi-constellation. We are focused on supporting all available GNSS signals and systems which are available at the time being. We support multi-frequency bands, and it is a quite important specifics that we support NavIC S-band signal, let's say in full, along with the rest of other GNSS signals. We implement positioning modes such as usual standalone, and also we support ATK and PPP modes for high accurate positioning. Measurement precision is at the best level in the class of GNSS equipment. In other words, we perform at the geodetic level of accuracy in terms of measurement precision. Also, we support dual antenna GNSS models, which are developed for heating determination, and also we use MEMS-based IMU sensor inside our assembled devices along with GNSS boards. This scheme includes just a general schematics of one of our receiver that has got two antennas, two antenna inputs. These are RF front and digital signal processing accompanied with MEMS sensors and the processor which is used for position computation. This slide provides just performances in terms of measurements precision. So we track carrier phase observables at the level of 0.8 millimeters, and the accuracy of our position in ATK mode is below 1 centimeter at short baselines. PPP mode, the accuracy of PPP mode is 5 centimeters in horizontal and 10 centimeters in vertical planes. And we support a standard interface protocol such as ITCM 3.3, also NMEA and NTL binary are supported. We operate hidden determination units with a good accuracy. So at 2 meters baseline, we obtain 0.06 degrees in terms of hidden accuracy. And also we generate the raw measurements at the update rate up to 20 hertz. This slide demonstrates two of our OEM boards. All of them are capable of NavIC L5 S-band tracking. NTL107 board is the most recent board that we have produced. It supports GPS GLONASS multi-system, multi-frequency set of signals and systems. It contains 384 channels, and power consumption is about 2 watts. It's important to note that we support the concept of the open architecture. It means that it is feasible to upload the user software into our models, the software which may be developed specifically for the given application. It is possible to get an access to the raw measurements and use them for anything, including user own algorithms for high accurate positioning such as ATK PPP, for example. It can be considered as a platform which could be used for development users' own applications and products, and we just provide a mean for doing this task. Respectively, we support application programming interface with the Helios family. It includes free RTOS operating, real-time operating system, with a usual set of the methods for communication between different tasks such as semaphores, mutexes, queues, and all such things. Also, we support CAN interface, USB, and some others. Also, we support the access to MCU to the initial measurements. This slide includes information about our assembled device, and this receiver can play a role of the reference stations in the GNSS networks. It includes the concept of the open platform. It is multi-constellation, multi-bands receiver. It supports ATK PPP mode and is capable of generating raw measurements with update rate up to 20 hertz, with a usual set of interfaces and standards. Also, it should be noted it is possible to develop applications under Windows, Android, or Linux operating systems. It just depends on the board that um, are available inside of this receiver. So it's feasible to configure this receiver with different hardware in order to support um, various operating systems. And it's worth noting that it supports also quite impressive list of the wireless and wired interfaces such as LoRa, Wi-Fi, Bluetooth, and NB IoT, others. So all of them can be um, available in this receiver. Open platform for devices based on high precision OEM receiver models um, uh, is similar to the concept of the open architecture, and it provides again capability to upload user applications inside our GNSS receivers in order to make them specific for the given application, to make them usable for this or another application, and also it's feasible to develop commercial products based on this concept as well. Um, this slide just includes some pictures um, um, related to our antenna complex. It is deployed in Skolkovo, and it includes some Trimble antennas and Topcon antennas. So we have got this antenna test bench for precision tests and researchers in the field of high accuracy positioning. This slide includes our the results of our experience when we track NavIC L5 and S-band signals. We can see that both of the signals um, can be tracked at the level of 0.5 millimeter. So both signals are perfect in terms of its usage for high accurate applications. Moreover, we try to use NavIC signals alone, so and up to ATK level of performances, and next slides will demonstrate that. It is the demonstration of NavIC on the ATK positioning using dual frequency setup. It is this result we obtained during 1 hour time span in Minsk. Not perfect location for in order to work with NavIC signals. Nevertheless, we were able to obtain quite good results in terms of ATK performances. It should be noted it is zero baseline, so many sources of errors are compensated. It is another sample of ATK performances using NavIC only signals. It is Bengaluru, about 3 meters baseline. There were 6 NavIC satellites which were used for computing ATK NavIC only position, and the horizontal RMS was less than 1 centimeter as a result of this experiment. We work not only with our own receivers. This slide demonstrates what our algorithm, how our algorithms work when using measurements from Trimble alloy receivers. This data were recorded in Ahmedabad on March 24th this year. It was about 80 meters baseline, 7 hours time span. We also can see that we provide ATK level of performances in terms of positioning accuracy. And now I would like to demonstrate some results in terms of PPP positioning. We support PPP algorithms, and they are capable of working with any GNSS system and signals. It means that, for example, when PPP corrections become available for NavIC satellites, we will be able to use them along with the rest of systems and signals for PPP positioning. It is the result of static positioning. The horizontal
Zenavib, please try to complete your presentation.
Okay. And it is the list of IGS network which we obtained again in the in static mode. This picture shows the results in PPP kinematic mode, and we could see that horizontal arrow didn't exceed 5 centimeters when comparing PPP trajectory with ATK1. So I will conclude with a summary. NTLab is a design center that provides a development at any technical level, from IP components to the assembly devices, in cooperation with partners. It's important to note that no black boxes included. All key components of our devices are developed in NTLab. NTLab GNSS receivers support NavIC L5 and S-band signal tracking in full, and raw measurements are ready for further processing. We have developed ATK and PPP algorithms which are implemented into our raw receivers, and they already support NavIC only ATK positioning, and in-house PPP algorithms can be adapted to use of NavIC measurements. The concept of open platform provides full flexibility in terms of choosing the onboard algorithms that can be used for processing GNSS observables. NavIC signals provide very good performances in terms of both measurement precision and positioning accuracy. NavIC L5 S-band signals can be used alone for high accurate positioning, for example, NavIC only ATK. I would like to express our acknowledgement to Indian Space Research Organization for permission to use GNSS measurements from Trimble receivers, and also we are thankful to Elena Geosystems and Park Control for the help in data collecting. Thank you for your attention.
Thank you, Genevieve. I'm sorry that I had to cut short your presentation. Anyway, thank you very much, and please be here for the introduction session. Thank you very much. And then I'll now request representative of Hydrogen Geosystem, Jaideep Sengar, I believe, will be presenting. Jaideep Sengar.
Good afternoon, sir. This is Jaideep.
Okay, please go ahead.
Sir, Mr. Arup Das will take care of the presentation, right? He is on the line. Within a couple minutes, he will start the presentation, sir.
Okay, Mr. Arup, I would like to request you please complete your presentation within another 20 minutes. So we have a shortage of time. Please go ahead. Arup, please start your presentation.
Yeah, Dr. Banerjee, I'm trying to share, but it is not going. Jaideep, can you share from your side?
Sure, sir. I will try.
Yeah.
नहीं करनी पड़ेगी present. Sir, can you see?
Yes.
Okay.
Yes, go ahead. We can see it.
Arup sir, you can continue. I will just turn on the slides.
You can also carry on, Jaideep. There's no matter.
Okay. Then give me a second. Let me connect my microphone.
That's why the better way.
Arup, your microphone is
Sir,
please
sir, it's added. Can you hear me, sir?
No.
Okay. Give me a second.
Jaideep, we can hear you, but not Arup.
Oh, sir, I will present only. I will not present it.
Okay, okay, go ahead.
Okay, sir. Yes, yes, sir. Thank you very much, sir, for giving us the opportunity to present the Hexagon portfolio to you. Hexagon, we are the leader into technology. We are a technology-driven company who are into various fields in sensor and the software. Sensor people knows very well, like a geosystem sensors. Earlier it was a wild and other satellites, total station and other things. And the software people knows about very well about the ADAS imaging. We are leader into image merging and the other areas, right? The journey for the company started for Leica system. It's somewhere 1800 century, right? Then up to that, 1988, up to somewhere about more than 100 years, we carry the same name, Kern, right? Then after J Kern, it's the company turned into in 1921 Wild. The people knows Wild T1, T2, and T3 satellites. They are very testful satellite, which delivers a very accurate measurements, right? The journey starts from here while to Leica system up to 2005, right? Then somewhere in 2005, parent company Hexagon they take over the Leica systems, and now it turned into Hexagon G system, right? So now we are carrying the name like Hexagon G system, and you can see the journey starts from that maps, normal PDF files or some drawings. Now we are coming to digital solutions. Everything you can put on the laptop, on your laptop or smart tablets, and you can go on the field and generate the drawings, data, everything you can do on the field itself. So today I am going to present a solution on like a GNSS. So in GNSS we have many things to show you. Out of that, few things I will try to capture for you. The journey for the GNSS in this organization started in 1984. It was the first GPS which can track the GPS signals. Uh, the time for centimeter positioning, it took somewhere 4 hours to 12 hours. The journey starts from here, and right now we are taking less than 4 seconds to give you a position. Right. So starting from the heavy system, it's a very bulky and giving you the data. We move into clear track where we are measuring the data within somewhere in less than an hour with the, and then coming down to minutes for centimeter level data. Then we develop a new technology where we can track the GPS and the GLONASS signals, right? Then we develop a technology in 2016 and come up with a sensor which can track the multiple frequencies as well as the multiple constellation right now available. For example, GPS, L1, L2, L5, and GLONASS, Galileo, Baidu. And right now we are also able to track the INSS signals. Then company come up with a new sensor which is called a true tilt sensor. It is the first tilt sensor which is calibration free and immune to magnetic disturbance. Then from here, last year only we have released a new sensor which we call GS39. We put a camera into a sensor so that you can capture the images as well on the field, and later on from the images you can drive the point cloud uh, for better understanding. So let me explain the technology, what we are doing right now. We are giving a future-proof GNSS technology. Means right now you can measure the GPS, GLONASS, Galileo, Baidu. Apart from that, like for example, right now we do not track or signals are not available for civilian use. HAS signal for Galileo E6, but our system is ready and compatible for E6 signal. So once the signal will be available in 2023, you not need to replace the complete hardware. You need to just put a key or authentication key to track the E6 signal. That's it. So with this is we call future proof GNSS technology. Then we come up with the technology called smart check. What happens when you go for the article survey on the field? It is very important to understand whether whatever data you are getting right, it is the accurate data or not. Because when I say 8 plus 1 ppm accuracy we can deliver it to you, we maintain a double check on that accuracy part, so that whatever we are claiming as a company side, our customers should get that data. Then we come up a solution called a smart link solution. In case somewhere you do not have an internet connectivity for entry particle services, or you cannot establish the radio article services, but you need a centimeter level position on the ground without any base station, because it could be a too far, or it is not easy job to establish a base or ground station for you. So you can go with the smart link services, which can be which are delivered by a satellite similar to Gagan, right? So these are the correction parameters coming from a satellite, and this correction parameter will be taken care by the sensor, and software process and give you the centimeter level data without any base station. Then we just one small video about the tilt sensor. So earlier what happened, you need to label the pole, then take a measurement, which is really a time taking exercise, right? So with tilt sensor, you not need to label the pole and continue your survey. So how we are doing it, it is important to understand. We are using just an IMU, inertial measurement unit, to get the information about the direction and the angle from of the pole. So which can deliver you 0.01 second angular accuracy, and it is very fast. It can measure the data as soon as 0.5 second, right? So whenever you move your steps, right, it understand where you are moving it, and so it can take the data, apply the correction, give you the same reading what you are getting into vertical pole. So it is a patent technology by the Leica, and it is a calibration free, immune to magnetic disturbance, and the most reliable results will on your screen. And most important part of this sensor, that it can work into any place, no matter you are into heavy construction industry, you are building, your normal topographical survey, anywhere you can go with the sensor, collect the data as per your desire. I have shown you that there's a normal sensor which can track the GPS, GLONASS, Galileo, Baidu. That is the one part. And then the next sensor which can give you an important parameter that you do not label the pole, but still you can get a same accuracy. So what next? That is important. The next thing is from the imaging. So these are the normal things. Imaging means if I'm not reachable to a area, still I have to capture the area. How could I get the data for that area? So a sensor, a camera is built into a sensor, the same GS18 sensor, right? Once you walk, you capture the data, and from the data you can collect the points where you want it. So it is a safe, and you measure the data from a distance, right? So sometimes people do not allow you to enter into premises. So this way you can mark the point and get the data. So how we are doing it? It's important to understand. We are doing it using a GNSS sensor, which give you a clear important parameter of the GNSS. Then we have a tilt sensor, which telling you where you are moving it, and the camera. It is the capturing the image, and all three are processing on a single platform and out giving a good results and output for you. So for another example, this is a pipeline, and it is important to track all the information of the pipe lay down in the area. So earlier, what happened? You have to go inside and take the data. That is a risky challenge, and it is a, maybe some event can be mishappening can be done with the survey. So now with GS39, just from a safe distance, you measure all the information. So right now you can go anywhere. A small video. This is a building, right? If I ask you to measure this coordinate of the building with the normal sensor, it is really tough. You ask to go with the scanner kind of thing and capture the details. But with GS39, a person needs to just walk. He's walking on the left side, and the data, whatever the camera is seeing, it is on the right side. So with the safe distance, you walk along with the building, and also you can see the capturing time, right? So up to 60 seconds of the data you can capture it, and you can store into a group. These photographs will be captured into a group, and you can rename or give any name to a group, whatever you feel suitable, right? So after working, once you think it's done by me, so you put a stop button. Once you press the stop button, it start merging the data. Once it will merge all the images, so 99 images has been merged into this group, and the average quality of the images is just 9 mm. So it's a quite good accuracy on an image, right? So after capturing the image, just open the image where you want to put the data, right? Put the cursor and say measured. So it is very simple to measure any point after capturing the data. So this way you can mark the points on the image on the field itself. Once you're done on field, you can come back to your office. Maybe some data has been left, or your office person wants need more data from the image. Import the data on like an Infinity software. That is a powerful software which can handle the GNSS data, TPS data, and as well as the UV data. So all the data can be put into single platform, supported by OpenStreetMap and the ASRI Google Global Maps, right? So it can tell you about the location information as well where the data has been captured. So if you zoom the data much more, it will tell you what kind of images has been captured and in which routine it has been captured. So once you satisfy with the import part, so you can click on scan point option. It will generate the scan data of the image. You can turn on the images, just open only the scan. So you can see it is a wonderful scan data from the images. And now you can measure anything, whatever you wanted. Even though you can do a you can do a redlining as well. And if you want to zoom into certain parts, you can do that. So if I want to highlight some portion, so I can create a box. So that portion will be highlighted for me, right? And because I want to do redlining or some, I want to more information I want to gather from this piece, so I can highlight it and do a redlining and marking of the building. Right now you can see when I mark a building, it is telling me the length of the line as well. That is a one case where it could be a good support for the municipal areas or those who are working into city areas, and it is they people do not allow them to enter into premises. This is another example for those who are working into construction area. They drill something and they want to create a mesh out of this area. So earlier what happened, people go to the total station on GNSS, they capture the data every 1 meter, half meter, 10 centimeter as per the requirement. But with GS18 you just move with the sensor, capture the details, put the data on the software like Infinity, again the same software, and create a scan data or from the images. Now we need to create a just cross section, long section from the data. So we'll select the area where we want to create a cross section or long section, or if we want to do a calculation for the volume, we can do it. So mesh I have created it. So you can see a triangulation from all the points. Now we'll select the area. For that, what I want to create a cross sections. So only these points will be collected, and I can generate it. Okay, so what are the advantages of having this kind of sensor? The first thing is that you are capturing the 100 points in a minute rather than in hours. Earlier in GNSS, it took hours to capture 100 points. Maybe sometimes it's a complete day. So you are saving the time. Second thing, you not need to worry about the obstruction you are getting on the field. So because you are getting the data from a safe distance, with this kind of sensor with GS39, you can capture even a difficult points as well. So it is a matter of safety as well for us. Then you can capture the side scenes possible, right? So it will help you to increase the productivity. So in a summary, I must say GS39, it's a visual positioning technology we are offering, which is a fusion of the GNSS, IMU and the camera. It is very easy to use with the survey grade permanent accuracy. That is very important point, that we are delivering survey grade accuracy with this kind of sensor as well. It has the same functionality what a GS18T sensor can do, plus our imaging capacity has been added to this sensor. We are offering a like a captivate field software, which is a very nice software, can run on a like a proprietary controllers or any Windows tablet. So in this case, you can bring your tablet as well, where we can run the like a captivate software. With it has a functionality for image capturing as well as on-site point measurement. The same thing can be extended to a 3D point cloud using the Leica Infinity Office software. And obviously we have to claim that it is the fastest GNSS rover in this world, right, where we can capture many points in a minute. It's innovative, it's fast, and it's versatile sensor. What are kind of the value we are delivering with the GS89? You can save your time using just one sensor. You are going complete day job you can do into hours only. So you are saving time and manpower. You can reduce your costly overheads like field works, measurement later, or sometimes repeat visits are required. So everything we can reduce with this thing. So we are delivering a value imaging with GS89. Also, you can reduce your overheads, access, traffic management, everything. Work safely means a price, yes. It is in a single slide. I have tried to explain that we have GS39, the highest GNSS sensor from the Leica and GNSS. Then we have GS18T, GS16, and GS07. These all are the integrated GNSS receiver. Receiver means in a single housing we will get a board, battery power, and other facility in a single housing. Then we have another sensor which we call GS10 and GS25, where we are making still the separate antenna and receiver facility, because still in research work people prefer a separate antenna and receiver to make the noise low as possible.
Jaideep, please try
Done,
to
sir.
conclude.
Sir, done. This GS39 was the world's first GNSS smart antenna with visual positioning. We say everybody knows the purpose is always good, but the share purpose is always better, because both will be in a win-to-win situation. And that's done from my side. Thank you, sir.
Jaideep, and
Thank
I would request Jaideep and
Sir.
Arup, please be with us and so that you can join in the introduction session.
Sure,
Thank
sir.
you.
Thank you, sir.
And now next presentation will be given by uBLOX. I don't know who will be presenting. I have two names. Alexei Negi will be presenting. So I request Alexei to please give your presentation, and again, please remember, please complete your presentation within another 20 minutes. Thank you.
Thank you. Can you hear me? Just want to make sure.
Yes, your presentation is visible.
Okay, thank you very much for confirming that. Thank you for allowing us to present to you. My name is Alex Gee. I'm the product manager for the ZF9R, and I represent uBLOX. Yeah, I think the message here for this product, we're basically a company that has a wide portfolio of modules and chips that are used in many applications, and yeah, we leverage the innovation of our customers to build high quality end products. And we have very high quality devices used often in the automotive industry. And I think this is kind of a bit of an offshoot from there. So, yeah, so my presentation will not be so much about lots of performance figures and particular products. I just want to highlight two applications to you that may be of interest. I realize that some of these are a little bit strange depending on which countries you're from. So, but yeah, so from an HPG point of view, high precision GNSS, we basically see kind of 5 different segments where we're used for drones on the left, surveying, as our previous speaker has shown. Surveying is also an important market segment. And then precision agriculture is another one, which I will talk a little bit about and how our product could help there. And of course, heavy machinery for construction. And then there's a number of specialty vehicles, and I'll also spend some time on that. Yes. So the F9R product is a high precision sensor fusion product that's somewhat derived from the automotive side. If you compare, I think that the innovation that uBLOX brings in this market segment is that we are targeting the higher volume markets. And what we've done compared to the previous generation of devices is that now we are operating with dual band receivers, operating in L1 and L2, and L5 in the coming devices. What we have, the devices natively understands correction data directly in our modules. We have RTK algorithms implemented directly in the modules as well. And of course, we have the 3D accelerometer and 3D gyroscopes. And all this is merged in with our sensor fusion algorithms to deliver the the best position output that you can have for your applications. So we fine-tune our dynamic models depending on what kind of devices we're using. So for the latest additions have been scooters and lawnmowers. And yeah, and we specifically validate our designs and fine-tune them for these applications. Yeah, so the way we see our GNSS system, just as an overview for you, is that we focus on scalability of the solution. As I mentioned, I'm looking for something that can operate with hundreds of thousands of units in the field and can be updated and receive corrections. So we have this receiver that our system includes the GNSS receiver, which has the embedded RTK. And the way we have it this way, because we don't want the users or the designers having to deal with the complexity. So they should get the best solution from us. And our GNSS receivers are done so that the host implementations can be simple. We can, and while maintaining security, so that when correction services are delivered to us, we are protecting the intellectual property of the correction service provider, and also ensuring that you're getting a reliable and trusted source of corrections. And so we see correction services being delivered over the internet, some kind of cellular connectivity, or over satellite, and we provide the chips and modules for that as well. I think that's all I had here. So the way we basically have a turnkey solution that incorporates everything in there, and we have quite a lot of flexibility that allows customers to tune their solution. So, for example, you could feed in more precise sensors. So if you want to spend a lot of money for a IMU, you can do that and still rely on our dead reckoning and our mass manufacturing approach to these modules. Okay, so I will go ahead with one of the examples. We have, so today I'll give you a little bit discussion about these scooters. I know that probably in India, what you view as a scooter is probably more this thing on the left. In America and Europe, these are getting quite popular as a shared vehicle. And I'll spend a little bit of time on that. And of course, the same kind of concepts work for these shared bicycles as well that are popular in European cities. So this is kind of how they look. You'll see them in Europe where they have charging stations, and these are called kind of stationary bikes that people can rent. And then of course there are also scooters, and they call these free floats scooters. So you can basically park them based on city regulations, and I think that's where we try to help the operators improve their revenues. So what we see, that there's been lots of studies about how micromobility can work. This is something that I got from a McKinsey report that's online, and the business model is quite attractive. I mean, we basically, by operating a few trips per day, they're able to, one of these these operators is able to make a good, strong business case where they can recover the cost of these bikes and very competitive pricing compared to buses and other forms of public transport. We view it as a very green and sustainable approach for transport, at least especially for kind of the last mile. And yeah, we also see post-COVID that they expect more people be would like to use such vehicles instead of getting onto a crowded bus. And then we also see that the substantial portion of the business is on the maintenance of these and moving around these fleets, and so there's opportunities for fleet managers. So for example, so where we excel with an HPG product is that across the US, for example, in many states and cities, that they'll have different regulations of what is allowed to use these things for. And so some places will want you to drive only on bike lanes. Some people will tell you to drive on the sidewalk, and some people say on the road, and some say that, and all this regulations for a shared vehicle can be used to to make it safer for everybody using such systems. And what we offer, we have a service, a satellite service or a correction service, and we have innovative cost models for how we can help these providers. So for example, they can get a license where they get X number of hours of operations on their entire fleet of scooters, and only use it in the certain cities that need that type of correction service. So, and this is a feature of one of our services called Point Perfect. So what the user, a typical application that we see is, so here's some screenshots of Bird, who's a leading provider. So for example, on your phone, you would get the map where the Bird scooters operate. And then, of course, when you're driving this thing, you're not using the phone, right? So what happens is they will have certain restrictions. So it's used to enforce speed and parking policies and operations. So for example, in this one, you would see that in a small part of town in Zurich, you're only allowed to drive slowly. So the scooters are throttled to operate slowly. And then here in this park, that you might not be able to park, but by having the maps onto the system, you can drive full speed, and that's where the customer values the high accuracy of our dead reckoning solution, so that they know that they're here versus over here where they're not allowed to drive, and how fast they can drive, and the system controls the user in terms of what they're allowed to do with the scooter according to regulations. So I'll show you just a little bit about the accuracy here. There's the red is basically the F9R in scooter mode. That these are the red points on the map. And if you have bikes with a bike mode, so which is not what you need for a scooter, or if you don't have RTK, which is blue. So here you have three cases. A fixed RTK solution is the best. So here you can see that the red is right on the dot. And then on this one, you can see this is a more challenging environment with more buildings. So there's a mix of fix and float solutions that are on the bike lane. Whereas if you don't have RTK, you're out reporting positions outside the bike lanes. And in this case, where it's even more challenging, we have a float solution on the sidewalk, and in some cases it's even reporting when you're not using the right dynamic model or the scooter. So this can result in very poor performance. Yeah. So so the way we help our customers build, we even give we have a demonstration scooter that can be brought to different places. And so that people can see how well it works. It's very simple. We have a GNSS receiver that hooks onto the hall sensors directly from the motor drive system. And all we do is we clean up the signal a little bit, and then we use that as Realtek. So very easy for customers to evaluate our product. Yes, and so talk to our sales if you're interested in that type of business. Finally, yes, I think I'm not going to present that there's nothing new in terms of technology that's here. I think the main point here for us is that there's a known market for precision agriculture. There's different applications where you have these very small robots that are moving and monitoring the fields. We all have an interest in maintaining the sustainability for in our planet in terms of how many seeds and pesticides we use. And I think there's lots of systems where you have assisted steering and light bars that people are building. And I think uBLOX is interesting for somebody that wants to build such aftermarket products. We have a very cost competitive solution, and we see India as a large market. We've seen various reports that we need pass-to-pass accuracy of 10 to 30 centimeters with very high repeatability. This is from the GSA report on agricultural user needs, and yeah, I think our products fits very well here. We see also that in India the farms are very small. They very small farms, and a lot of tractors are sold here. And clearly the very large tractors that are being sold, combines and so on, that are being used in the US is not applicable to these small farms. And so by uBLOX providing a very cost competitive small product, I think there's a substantial market here for our dead reckoning technology to be used in the farms. So that and what it does for people is that when the tractors drive around, you can have very little overlap and very efficient coverage of the farm field, and can reduce the overuse of pesticides and reduce the cost of seeds. Yeah, so just as a reference, it depends on the type of crops. If you have RTK technology, you can have very precise application of seeds, and you can select the different correction services, and using a correction service based on PPP RTK, which is our point perfect service, you can kind of achieve that level of performance. So in summary, the ZF9R is our high precision dead reckoning product. It's a multi-band GNSS receiver delivering centimeter level accuracy, fully integrated solution for fast time to market. And we have very specific dynamic models for slow moving service robots and delivery drones, and also for scooters. And we're compatible with Spartan SSR correction services for easy and efficient implementation. Thank you very much for your time and attention. And if you have any questions, you can contact Niaz Majid, and he would be happy to help you.
Thank you, Alex, for your excellent and brief presentation. And I would request you that you and also Niaz Majid, please be here till the end of the session when the introduction will start. So with this, let me switch over to the next presentation. It will be given by the Trimble India. I do not know, I do not have the name who is going to present. Anybody representative for Trimble India may please come up.
Sure, sir. I don't think so. I have the option to share my screen as of now. So if somebody can allow that, that'll be great.
You are representing Trimble India?
Yes, sir. My name is Sanjeev Trehan.
Sanjeev Trehan.
That's right.
Okay, Sanjeev Trehan, if you belong to Trimble India, you may please go ahead.
Is my screen visible, sir? Excuse me. Is my screen visible to everyone, please?
Yes, yes, visible.
Okay. So moving very quickly along, my presentation is not going to dwell too much into technicals, accuracies, etc. But I've been there, done that, talked a lot about. I think this is a very erudite gathering, people knowledge. I would like to leave everybody with information on what is happening in the contemporary world of GNSS and technology. And when I talk about contemporary, all these solutions are, as we speak, being implemented in the country. So just a broader, moving beyond basic XYZ, how we utilizing GNSS, that's what the emphasis is. And it's very difficult to cover it in a 20-minute session, but I'll try to leave you with a highlight of some of the points. And then, I can share additional information, later in a one-to-one on offline mode. First of all, thank you very much to the University of Burdwan to have me here. It's a pleasure, and I hope the interaction is meaningful for everyone. So to those of you who are not familiar with Trimble, this is a quick snapshot. Trimble is a $3.125 billion company with a tremendous amount of investment in R&D. Last year alone, we spent around $475 million in R&D alone. We have more than about 1,000 people in India. Roughly around about 10% of Trimble is represented today out of India, and we have offices in more than 15 countries, and customers in more than 150 countries per se as such. Now, when you talk about Trimble, Trimble is metamorphosized from what a lot of people knew from the early 90s and or late 90s and early 2000s. Today, the theme is, the best way to describe Trimble is trying to transform the way the world works. And these are the core industries that Trimble is developing solutions for: agriculture, building, civil engineering, construction, geospatial, which covers survey, transportation, logistics. And there are a host of emerging technologies or areas or domains that we're working in, including railways and many more, oil and gas, mining. These are other emerging sectors, as we call. So a lot of our solutions are getting metamorphosized into solutions for these particular sectors, where we're trying to address the entire workflow. So Trimble started off as a positioning and a sensor company, evolved into using communication technology, utilize that, gone into modeling and all. And today the focus is into analytics, asset optimization, workflow management, and yield management in multiple domains. So focusing on GNSS solutions, I would like to introduce some solutions that we have in the market being used in the country in different segments. In terms of evolution of GNSS technology, I love this photograph. I've had it with me since late 90s. This is how a portable GPS was, bulky equipment. I had this piece of receiver with me for many, many years. Unfortunately, I disposed it, which I regret today. But this is how the technology used to look like. Today, we're talking about miniaturization of technology. And the only thing that restricts us from miniaturizing further is how much capability can we pack in a particular receiver or a board. So a lot of transformation has taken place over the years, and Trimble has been in the forefront of doing that. There have been many firsts in terms of innovation. There's a very, very long history of innovation for those people who are not aware of what Trimble has been doing. Apart from becoming of the first commercial receiver, the first RTK receiver was introduced by Trimble, and then the world changed after that. A lot of the applications that people are using for, whether it's for cadastre, construction, topographic survey, etc., utilizes RTK technology. Trimble also introduced virtual reference stations to the world, and I'll talk about it a little bit later. So the many firsts, I won't go through it, but that Trimble is credited with, and they built the foundation for the GNSS industry as a whole on a worldwide basis, and including in India. Focusing to start off with on the survey side of the business, or the geospatial side of the business, there is a host of products which are available in the market that our teams supported by distribution partners are pushing the market. At the top of there is the R12 and R12i, which is an extremely popular and a high-tech receiver today, possibly the most technologically advanced receiver in the market available today. Trimble Alloy is the backbone of a lot of your geodetic programs in the country, whether it's the Earth Sciences project, whether it's CoRS networks which are being laid in the country. Trimble Alloy is possibly in a very, very unique position, that it was one of the first receivers which had a complete support for L-band, S-band tracking, especially in the NavIC domain. R8S and SP80 are workhorses. R8S is possibly the most used receiver in the country today. We have hundreds of these receivers being used by governmental organizations as well as private surveys. You name it, and every corner of the country, there are people utilizing these receivers, all packed with wonderful technology. And I won't get into the specifics. In case there is any interest, I'll be very, very happy to arrange an interaction with our team, or I will personally share information with everyone. Spectra SP80 is another wonderful piece of receiver. It's a modular form of receiver, and very, very robust system, which has been used by many customers for a base station or a rover application. Now, I'd like to utilize this opportunity for the first time in the country. I'd like to introduce the Trimble DA2 Catalyst software GNSS. So treat it as a launch, but this is the first forum that we are introducing publicly in the country. So Catalyst, this is the second generation of Catalyst solution. The first one is called DA1 antenna. This combines a relatively low-cost antenna called DA2 with a software GNSS. So we've taken all the algorithms, etc. We've taken all the hardware component, created an app out of it, and it leverages the electronics or the chip which is there in your smartphones. So instead of giving you a receiver, we are trying to utilize the smartphone that is basically available with nearly everyone in the country today, especially India, in fact, entire world. So wonderful piece of technology. DA1 was a great piece of equipment. DA2 is extremely powerful, and very happy to tell everyone that it supports L1, L2, L5, and L5 NavIC as well. So the idea of coming out with DA2 is make it approachable for users across the entire gamut of industry. It is kind of a hardware as a service, you can call it. You can take subscription depending on what your requirement is. You just need to procure an antenna, and then you can pay for the subscription of utilizing either a meter level service or sub-meter level service or centimeter level of service, etc. You can use different forms of correction. You can set up your own terrestrial base station. You can use satellite-based correction, etc. A wonderful piece of technology. Going forward, you'll be hearing a lot about this particular piece of technology, especially since there is a network of core stations being planned and executed across the country as we speak. That brings me to the next subject, virtual reference stations. You cannot discount virtual reference stations the moment you talk about GNSS. And I mentioned Trimble Alloy has been a backbone for many of the scientific as well as the course projects. So VRS is, if I put it in a very generic language, is an RTK course network, or network RTK course network. Trimble launched this technology as far as 1999. It's taken, my first presentation on this technology was in 2004 in India. And it's taken many years for India to finally establish a center. We commissioned the first network in the country in last year for UP, Uttar Pradesh, Uttarakhand, and the World Bank aided water resources project under Survey of India. Happy to tell you that it's been running successfully, and there have been more successes subsequently. I'll be happy to share information on what our VRS is all about, but ultimately it does away with everyone using their own base stations. Everybody uses a common reference framework, which is going to change the way we operate, the speed at which we operate, and make certain operations possible, which otherwise take a lot of time. Just imagine you land from Bombay into Calcutta, you take out a phone, you turn on your phone, and you start receiving a signal. Similarly, it's going to be like a surveyor can just walk out of an aircraft from Pune, he can fly down to Calcutta, turn on his GPS receiver. As long as he has the password to get into the network, he can start using it. Imagine a system of GPS stations, just like your cell phone towers, spread all over the state, all of the district, and the country, etc. And if you have access to it, you can go and use that to carry out accurate surveys. So this is what's going to happen in the future. People will be utilizing in the country as well, finally. Just in case people are interested, how it works, there's a network of receivers getting in data to a centralized server, and the rover receiver, which has got permission, connects into the server, and the server generates a position or a reference station, etc., next to it, and the user gets a corrected position as long as he's within the periphery of these stations. A very, very powerful tool, which is going to change the way we work. Just to give you an example of what's been happening, so we have set up a 73 course network in Uttar Pradesh, Uttarakhand. As I mentioned earlier, 126 are being installed in Haryana, Punjab, Rajasthan, Himachal, nearly completed. 90 are being set up in Madhya Pradesh, and we are also establishing a 60 course network for the high-speed rail network from Gujarat into Mumbai. This is a very interesting map. May sound confusing, but very interesting. This was one of the first tsunami warning centers and earthquake deformation monitoring centers which were established. Trimble was very much a part of it, where we had contributed with our receivers and software, which is running in real time at Incois and IMD. Again, the predecessor for the Alloy is very much embedded out here. So for those of you who are not aware, Trimble has been a very, very rich contributor to the earthquake monitoring program in the country, as well as the tsunami warning program in the country. If you get an opportunity, please go and take a look at the wonderful setup that is there at IMD and Incois, where you can see real-time deformation taking place. This network has been used to predict whether a tsunami is going to occur or not, using various algorithms which are being developed by these two facilities. So a lot of work, a lot of effort has been went into creating the setup. A lot of customization was done for India for this project as well. So there are many possibilities that are there. So if there's a problem area, it can be defined over a period of time. A solution can be presented for those problems. As I mentioned, Alloy is the backbone. A very, very quick look at what this series is about. A wonderful, rugged piece of equipment, extremely user-friendly, and we have hundreds of these working from Himalayas, from Northwest Himalayas, east to the plains of India, etc., without any issue. Moving along, we have a very, very robust portfolio of precision board and OEM solutions, which are getting embedded into various applications, whether it's autonomous vehicles, whether it is autonomous tractors, whether it's defense systems, whether it's UAVs. A lot of these boards are finding their way into the technology in the country and all across the world. So we have both box products, which can be retrofitted into various equipment or platforms, or board level product which can be integrated into a solution depending on what the requirement is. All but two systems are L5 NavIC ready, so they support multi-constellation L1, L2, L5, and I can share. So there's a mix of both single antenna systems as well as dual antenna system to take care of heading requirements per se as such. I can share additional information depending on who requires what. So it'll be my pleasure to share that. I also, apart from other things, I also help this particular side of the business in the region and support their activity with various customers around the country. Another part of this business is the Applanix solution. So this is just an image of how the system looks like, the box solution and the board level solution. Is the Applanix solution. Applanix has some core competencies, including the main competency is marrying GPS and IMUs and calibrating them extremely finely. We have solutions under the Applanix brand, which are operating in drones, in mining environment, in marine environments, along with UAVs, etc. So as I mentioned, direct georeferencing is a proprietary technology that Applanix has. Conventional GNSS receivers, when embedded into UAVs, you require around about 70 to 80% overlap. Applanix DG core technology allows UAVs to operate with a 30 to 40% overlap, thereby increasing the coverage of the UAV, leading to productivity, as the data set which is collected is smaller and it's faster to process. You also don't require multiple ground control points. You just need a base station and operate in RTK or a PPK mode. Wonderful piece of technology. I'll be happy to share information on the OEM side of the business with anyone who's interested, anyone who's willing to develop the solution locally. And as we are supporting many people under the Make in India program, where these sensors are getting embedded on various platforms. So these are certain target industries where these sensors are being used. Another information I'd like to share is we're looking at a GPS in a pure GPS way, XYZ, right? Most of us are familiar with the where GPS is being used for survey technology, or today there's a lot of awareness as far as UAVs is concerned. But one of the areas which is gathering steam very, very quickly is on the construction side, where today GPS is embedded on various machines. This is an example of just one machine, but there are multiple machines, multiple sensors where GPS is getting embedded, so that you can have a day or night operation. You can reduce your cost because rework is reduced by using these sensors. So don't look at GPS purely with what's been used for historically. Look at various ways of utilizing GPS down the road, and that's where fun is. Look at the application you can use the core technology with, marry it with software, and that's what Trimble has been doing. So Trimble is metamorphosized from a purely sensor-based company into a solutions-based company, into a workflow-based company by marrying innovative software solutions with positioning technology. So this is just one example of that. Today we have got multiple projects ongoing in the country where it's being deployed on rail, on highways, and on airports, where 3D machine control is adding a lot of value, working day and night. This just shows the kind of productivity which is achieved by using various platforms. And I'll be again happy to share anyone who wants information on this particular aspect of the technology as well. One aspect that a lot of people don't relate at times is GPS also presents a very, very robust timing solution. Today, our timing solutions are embedded are a backbone for a lot of your telecommunication networks. We have, without getting into specifics about which all service provider, our Thunderbolt solutions, our OEM solutions are embedded in a lot of our telephone network. And whether it is your synchronization every time you use an ATM, there is a part of Trimble which comes into use out there. So this is just an example of different ways adding value in the country as well. So these are some OEM solutions. There are people who are creating around these boards and the latest I've done is down below. We just introduced a L1, L5 GNSS timing module, which is extremely small. We expect we've got a rave reviews on a worldwide basis, and hopefully this will be doing pretty well in the country as well. And now I've talked about certain receivers very quickly. Certain core technology I'll just talk about and share some additional information on a one-to-one basis. As I mentioned, R12 is I guess the most advanced GPS receiver in the market, extremely reliable. There are certain core technologies packed into the receiver. There's one technology called Trimble ProPoint, Trimble Tip. These are two technologies. Apart from that, there is RTX Infill, there is HD GNSS, etc. I won't go through all of them since time is of the essence. I'll just talk about a few of them. Trimble ProPoint is a 5th generation high positioning engine, which is engineered to provide position, orientation data from fusion of GNSS signals, high accuracy correction services, and measurement data from a variety of sensors. So ultimately, what it's doing is increasing your reliability, availability, integrity, and increasing your constellation support. So ProPoint allows us to actually take NavIC into the solution as well, very interestingly, and allows you to operate in a very, very tough environment. I have personally seen the operation, and there is extreme amount of productivity enhancement, since you are able to operate in very difficult terrain and very difficult environment by using this particular technology. Under trees, under urban canyons, in mountainous terrain, etc., the productivity is actually tremendous.
Sanjeev ji,
yes, sir.
I would request you to please try to conclude.
Oh, okay, sir. So very quickly, couple of slides, then I'll skip. Is Trimble tilt compensation technology tip, where you can operate in inclined mode. I guess it's self-explanatory. I will not spend too much time. This is just talks about what the basic backbone of the technology is all about. A Trimble ASIC with 672 channels, which has got built-in, packed with a lot of technology. Now, very quickly, Catalyst technology is what I mentioned earlier. A software-based GPS receiver, uses Android or iOS, uses Bluetooth to connect between the antenna or your phone or a tablet. Very lightweight, a subscription-based service. Highly accurate, as you can see, as accurate as a conventional GPS receiver. Now, the last slides is all this technology. What's next? What's happening? What are the trends? So there are plenty of, but I like to plenty of trends. Just like to leave it with two. What's happening out there? We see a lot of AR, augmented reality, coming to the picture. So all our solutions are getting geared up towards that. So where you can carry your design and marry reality with what you call your design aspect, and compare. Go to the site, compare. This is a design. This is a reality, and look at how it looks like. This is the future. So GNSS will be used in a big way, along with AR-ready devices. Another aspect is PPP. Trimble Center Point is gaining traction across the world. A lot of autonomous vehicle manufacturers have started using it. This is a broad coverage map of the area. We are providing a 2-centimeter service in North America and parts of Europe. In India, we have around about, at best, around 5-centimeter service, but things may change down the road. With that, thank you very much, and I'll be happy to address any questions subsequently or later offline as well. Thank you very much, sir.
Thank you, Mr. Sanjeev, and I would request you to please be with us till the end of the session, because then you will have an introduction session.
Sure,
so with this, now I'd like to request our last presenter is on behalf of V3 Novas, and the presentation is supposed to be given by Mr. Hemant. Hemant, are you here?
Yeah,
yes,
yeah, I'm here, sir. Yeah.
I'm here. I am seeing you. So you can please start your presentation, and please try to complete it within 20 minutes so that we have enough time for the introduction. Thank you.
Thank you, sir. Good evening, everyone. So myself, Hemant R from V3 Novas Private Limited, Bangalore. So can I request permission to share my screen, sir?
Show your screen.
Yeah. Okay.
Yes, Hemant,
Yeah.
we can see your screen. Thank you.
Okay. So basically, like we are the manufacturers of precise time servers, GNSS based time servers. So wherein like we have various versions of the time servers. So maybe like I can quickly start going through our products. So yeah. So this we call it a safe sync. It's basically a GNSS based time server, NTP time server, which is based on uBLOX engine. Nowadays, like we have even started using NTLabs, where like when customers demand for IRNSS L5 and S-band, we are using NTLabs for our time servers, which will be a GNSS engine. So here, like the main point of this time servers is the holdover accuracy. When GNSS is not there, what we are giving to customers is less than 1 microsecond for a period of around 24 hours. So that is the accuracy which we are able to achieve. And then we'll go to the next slide. So this is again, it's in the form factor of this particular equipment is 1U. and features like what we give with this is like one precise 1 PPS output and 10 megahertz output will be available other than the NTP server. And this is the NTP server wherein like many more clients can be connected to this server. So, and this is like all our products are MIL qualified. We have qualified both MIL 461F on the EMI/EMC side, and the environmental side we have qualified for MIL 81G. So, and mainly like right now our customers are Indian PSUs and defense sector. So, and I'm going to the next slide. So this we call it a SafeSync Plus, where other than the 1 PPS and 10 megahertz, we do have some frequency generator outputs. So mainly the iRig-B DC and iRig-B AM ports. And also we do have some fiber Ethernet and 1 gig Ethernet port on this. And we also give this iRig output on RS-232 and 485. So other than the GNSS NTP time server, we do have some frequency generation options. So, and one thing what we can do is like depending upon the customer's need, we can customize the number of outputs required for that particular requirement. So that is one flexibility what we have. And all our time servers are it can be configured for L5 and NavIC L5 and S band as well as GPS GLONASS. So that is one thing, one advantage what people have with our products. So, and this is the commercial NTP PTP time server. This is based on uBLOX timing module. So where the constellation supported our GPS GLONASS Galileo. So mainly we depend on GPS GLONASS and Galileo for the timing output. So this like we are giving to a lot of banks, Indian PSU banks, so to maintain their time. And third is this is the rugged GNSS receiver. So which is deployed in defense communication trucks. And here like this particular module is powered by GNSS module from Elena Geosystems. So, and again like this particular product is also qualified for MIL 810G and MIL 461F. So already like in this particular product, like we have also started working on integrating the Map My India maps, so which will be an offline map, so which will be used by our Indian defense. So on the third and this particular product is GNSS re-radiator. So basically this particular product, what we are doing is we are creating a virtual sky in your laboratory, wherein like most of the time like we will be bound to go out to get the GPS signals, GNSS signals. So where it becomes very difficult for people who are involved in testing of these products. So what we have done is like this GNSS re-radiator will help you test your products inside your laboratory. So in this, like we have various variants which starts from single channel, quad channel, 16 channel, 32 channel, up to 64 channels. So, and we do have a gain adjustment of 0 to 30 dB. So depending upon your area of interest, like you will be able to select the number of channels. So these are some of the products which are like based on GNSS, where GNSS timing module. So where like we are making use of GNSS timing modules for precise timing application. So I think that's it from my side. So if you have any sort of questions, like I'll be very happy to address that.
Okay, thank you for your
Thank you.
presentation. So now we have some time for the introduction with the manufacturer. So before I open up this session to the participants, I'd like to sum up what all has been talked about. The first presentation was by NTLab, and it was presented by Zinoviv, and he's also given a previous presentation, technical presentation on GLONASS. Then we got a representation from Hydrogen Geosystem. They have represented Hexagon and Leica system. It was presented by Jaideep in presence of his colleague Arup Das. And then uBLOX was presented by Alex and Najib Niaz Majid. I most probably I have seen him earlier. He is also present. And then it was presented on behalf of Trimble by Sanjeev Trayan. And also the last presentation was by V3 Novels by Mr. Hemant. And seeing all different types of applications, it reminds me of my days in uh, late 90s when I used to go through the GPS world very frequently. And they have given a statement that limitation of application of GPS. Now, let me convert this GPS to GNSS is not the technological limitation, but it is a limitation of your imagination. And this is very much true. And it is very much true seeing all your application, very innovative applications, and this is possible because technological advancement and unthinkable accuracy that GNSS is achieving these days. So it was a very informative, and I am very much educated by all your presentations. And with this, I would like to go to the chat box first, whether you have many questions, and so that you can start interacting. So you have many questions. Jaideep, are you going to put the questions one by one? Jaideep, please unmute your speaker.
I think Jaideep is not there, but this is Arup Das. Mr.
Okay.
Sampat Kumar Panda asked one question regarding smart station for like a total station model TS16 or any higher version. And Jaideep has already replied in the chat box. This is not developed for the smart station purpose, but we had some other sensors which could be used as smart station or smart port. So he has asked Mr. Samad to contact us. We can give him other solutions for that.
It's nice that many questions has already been answered by the speakers. Jaideep has already answered, though it is answered, so I would like that it should be also informed to the other participants. Now, Sampat Kumar Panda, he has got, may I got uBLOX representative contact details in India. We are interested to know about the Z and F9P and other application board or any newer version. And Niaz Ahmed and already Majid is already given his contact number. You can free to contact him. I do not see any other questions now. Any other questions? Jaideep, do you like to say something? Okay, if you're not there, I would like to open this floor to the participants. They can one by one come, open up your, unmute your microphone one by one, and if you would have to have a questions, or you can use your chat box. Any other question? Can you use your chat box, please? Yes, another question has come. That is Raj Gaurav. NTLab, what is the maximum data logging rate? It was said that 20 hertz position. Can we log velocity along with the same position?
Yes, they are the same PVT. So 20 hertz update rate means that you can compute the velocity on the same update rate.
Now Jaideep Singh, now Jaideep Singh has also answered. Does uBLOX have any? I don't know. I don't have. Yes, it is questions by Jaideep
Yeah.
Singh to uBLOX. Does uBLOX have any board which can provide RTK fix solutions on mobile phones?
The evaluation kits that we have for the ZF9P has Bluetooth and Wi-Fi interfaces, so you should be able to link to them. But we don't have an end product. We don't sell end products, right?
Okay, thank you. Any other question? Please come up in the chat box. Many new products is coming in GNSS with a very innovative application in mind. So that is very interesting. We have got another question, that is Sampath Kumar Panda. I was informed that NavIC S-band recording is not available in commercial receiver. Could anyone inform about the same? As even we purchase a multi GNSS receiver that is capable of recording only L-band NavIC. I don't know whether anybody would be able to that Colonel Velan was there. He would have been the best person to answer this. But here he is not there, I can believe. So I would request Sampath Kumar Panda to forward this question to Colonel Velan, whose number you will get it very soon.
Yeah, maybe like if I can answer him, because like
Please.
I think
Please, Hemant.
yeah. Any commercially available modules doesn't have S-band. Okay, so when they say multi GNSS receiver, it will be only constrained to L5 bands. L5 for NavIC. So it will be L1, L2, and L5. So no S-band is available as of now on any commercially available receivers. So it will be at this point of time, it is NTLab and Elena Geosystems who are providing the S-band, and even I think Trimble is having, but I don't think they are giving it in OEM form factor.
Thank you, Hemant.
So, yeah.
Just a quick follow-up point. There are two aspects when you're talking about S-band.
Please.
The first aspect is you have to have a suitable antenna, for one. There has to be commercial viability of it. It has to be an ergonomic form factor. So many applications, depending on the commercial applications, you have to look at the form factor of the solution. Number two, the RTCM approval is still pending for S-band. Tracking S-band is something different from utilizing it in a solution. So I think ISRO is working towards getting appropriate ratifications of that, and after that, you will be able to utilize that or leverage that particular solution into the solution per se as such.
Okay.
Thank you.
Yes. Yes, this is Alexey Zinoev. I would just like to add some notes to this statement. We NTLab produce OEM boards which are capable of S-band tracking, and we can output both NavIC L5 and S-band measurements in parallel. So in the sense, there is no difference between S-band signal and the rest of GNSS signals. All of them can be tracked and recorded without problems. Also, with respect to standardization, currently we are in process of S-band interoperability testing within ATCM. So this standardization has been approved by ATCM plenary meeting, and hopefully by January next year we will get some results that would allow S-band signal to be fully standardized at ATCM level. So thank you.
Thank you. Any other question from the chat box? We have some time, and all the experts from the different companies are here. So I do not find any questions. Now, in view of the questions, if any of the company representative would like to have some special comments, I would like to hear, if at all, anything they have to say.
So this is Jaideep. My comment is that only the industry is moving at a very fast speed, right? So lots of things coming up in the market, and new technology also we are introducing in the competition is as well. We are doing a big. We want to cover a big area of the applications like machine control and hydro features and other areas, right? And right now, India, like Survey of India, is doing an extremely good job where they are establishing a chorus network countrywide. So this will help India to move in a faster space, so where you can use any GNSS receiver and get a centimeter level of position in any part of the India. So I think the people think about how GNSS technology can be fit into their part, because we have lots of product and competition as well, right? So all these products can deliver you good solutions, and definitely they can solve your all problems. Just you need to ping us that so that we can provide you a right solution within a limit. That's from my side only.
Thank you, Jaideep. Now, before any question comes up, my request on behalf of Burdwan University and particularly on behalf of Dr. Ananda Bose, who has not been here today because of health reason. So I think we might be doing that, but I would request Bhardar that all the companies, whenever your new product come or new modification of a same product, please keep us informed. That will not only get us educated, and also we can think of a inclusion of those products into the future project plan. And also, and when you give that, you also give some estimate, rough estimate of your budget that is required. So that will help in planning the project and submit it to for the resource funding. So please keep it in mind. It might be doing it all of you, because when I was in National Physical Laboratory, I used to get the updates of all the products from different labs, particularly those days uBLOX were not there in early 20s, early 90s. I used to get from Trimble. Sanjeev might not have been active those days. He might be a student that time, or it was in 90s, and I have not got any. I used to get a lot of update from Leica also. Leica was very active those days, and Trimble was also. So but these days Anindya might be getting all these updates. So you please continue to do so, and so that we get updated always. Thank you. I do not see any other questions on the chat box. But in addition, as because we have some, yes, I got another questions. Can you list the development board available for baseband signal processing algorithm in real time? He has not addressed this to any particular company, but anybody would like to answer on it. Can you list the development boards available for the baseband signal processing algorithm in real time? Anybody can take up this question.
Sir, I request Misra sir to forward his contact to me so that I will let him connect with my Novotel team. Maybe they will have some solution because they work on the boards. Hexagon GS system works a complete end-to-end solution.
Okay, Chandan Misra, please contact Jaideep after this workshop is over. I think he'll be able to help you.
Also, I would like to add as a side of the Interlab
Please.
that we produce evaluation boards which are capable of outputting samples that could be used for baseband signal processing algorithms. So these boards are designed exactly for this purpose, to develop baseband signal processing algorithms using data samples obtained from RF frontends. So you could apply to NTLab and we will provide more detailed information.
Thank you, Dr. Genovese.
Oops. Thank you.
Well, any other question? Please go ahead. We have still a couple of minutes left before this close of the session. Yes, we have got another question from the Department of Physics. I don't know who has done it, maybe Jaideep. The question is, the commercially available GNSS antenna generally are active type, and this says that an amplifier is attached along with the antenna itself. In such case, what is the gain and NF required for such application? Nice figure. Anybody can answer it?
Sir, in Leica, our sensor generally produce plus minus 28 gain, right? But I'm not sure about the noise figure that I have to identify with team.
Dr. Okay, I don't know who has asked this question from the department, but anyway, my advice to that person who has asked, that Jaideep has already given some answer. You can write to them and they will get a proper answer from you. Okay, Jaideep, it is your question. Okay, you got the answer. Now, Chaya Verma has given a question. Which algorithm is being used to deal with multipath error in dense forest? Trimble. The question was addressed to Trimble.
Chayaji, I will forward you a little bit of documentation, some white papers, etc., which will dwell on the multiple technologies that are at play. It's a combination of the antenna as well as the chip, the Maxwell 7 chip that we use, and the algorithms which have been developed. So I will forward you some relevant papers which can be of help. If you can just email me your contact details, and you will have the information. Yes.
Okay, I can see in the chat box Sanjeev already given his website address, so you can look at it for more detail. Yes, Jaideep would like to say something.
So, recently we have developed a technology to cater this kind of problems, the multipath where you are into dense forest or near to a building area. So recently we have developed this kind of solution, right? So this is a complete part of this application. So no need to put it any additional kind of activation or something is required on that part. So it is a part of firmware. So whenever sensors works into a dense forest area or near the building area, automatically that start working, and it tracks the best possible satellite available, right? And it get a tick off the fractured signals, right? So always so that you can have an RTK fixed solution in any environment. And the next question is that, is there any commercial?
I think it is the reply from Sanjeev Teran that Chai, if you can send me your email to, he has already kindly given his email, Sanjeev, and he promised to share all this information. So please, Chaya, you act accordingly. Thank you.
Okay, so the next question is from Sekhar sir, right? Where you're talking about so that you can get a polarized signal reflected from the ground or some water body, right? So we have the solution where we are mounting two antennas, one at the top and the one at the bottom, 180-degree rotation, where we are tracking all these reflected signal. This solution has been implemented in certain cases. There are very few cases for that, but yes, we can do that.
Okay, Sushant, you have got the answer from, that is a good question. So, Trehan, Jaideep has already answered. You can. So, is there any question? Please come up. Okay. Jaideep has already shared.
Mail ID, sir.
Yeah.
Dr. Banji, just one reply to one of your statements. I've had the privilege of meeting you many years ago in late 90s. I think when you were looking at scientific receivers for ionospheric measurements, etc. So
yeah.
That's been a long time, long time.
Yeah. So that time I was quite active because I'm the person, let me say, when you have time, I can little bit digress. I'm the person, P. Banerjee, who started GPS signal research and use also. First time in India in National Physical Laboratory, I purchased one GPS receiver for timing application, which
Yes,
at that time is a 3-unit 19-inch rack system. From NIST, we have purchased it, and it was supplied by Allen Group.
Allen Osborne.
Yeah. Allen Osborne has
right.
given it. So that is the time I am involved in GPS and GNSS. Until now, I am continuing indirectly with, I'm the research advisor to Anindo's group, because Anindo is my also student who did PhD at that time under my guidance.
Sure, pleasure having you on board, sir.
So that is, so I'm so much attached to GNSS system for a long time. So it has gone into my blood.
Likewise, sir. Likewise. So it happens.
Yeah. So I still keep. Also, I am associated with the different universities, and I keep on giving talks in different forums. So I keep always myself try to keep myself abreast with whatever all happening around, and I try to do some work always whatever possible with the Ananda's group and many other group like Calcutta University radio physics group. I had some junior student who I'm advisor to them. And also I did some work in Amity University, and I'm still indirectly associated with National Physical Laboratory for their GPS activities. So I'm still there. So I have an old history. I was waiting, I was telling all these things because I was just indirectly waiting for the chat box question. Nothing has come. So it is the time. I don't like to hold all of you because we have come to the close of the session. So whatever I have heard from all these representative of the company along with the participants, so we'll have to treat ourselves as one family with a lot of members in that, and we'll have to grow all together. So, because it is a mutual interest, more will give you the problem, you will come out with the new products, and more you will use your products, more you will be able to look for more avenues for the use of your product and improve your product. So this cycle goes on. So so let us grow together. That is my message to all of you. Request that let us grow together, hand in hand, and exchange our all news and experience and share in a common platform. Yes, Rubena Khan, I am seeing your microphone on. Do you like to say something? Okay, maybe it was by mistake. Okay, so unless you all, the representative, I'm thankful to all of you. So we have come all the way to show your product and showcase your all products and give a presentations. I'm trying to see. So it is a very good session, and it was interactive. So all the participants got a lot of information. And with this, I'd like to thank you once again for being with us for a long time and sharing your experience. Thank you very much, and let us have a good day. And all of you, wish you all the best in your individual endeavors, and you grow. And let us have a nice time. All of us grow together. Thank you very much. And if you, Jaideep, do you like to say? Otherwise, I'd like to close session.
Just I want to sir answer one question asked by Mr. Sir. He was just talking about in the areas where it is not possible to reach out a point, right? How could I capture the data? So I must say we have launched two devices, that is like a GS39, another is FLX100. You can explore these two devices in these areas. What we have experienced it, these devices are able to capture the desired results and the data whatever you want to see, because with GS39 with a safe distance of 15 to 20 meter you can capture the image then identify the data. And the last, thank you sir giving me an opportunity to say something at the end and closing the session. It was a nice session sir, and thanks for giving us the opportunity to represent the Hexagon solution on the board. I hope so. The listener has enjoyed the session from Hexagon and the other presentation done by the people. And thank you very much, sir.
Thank you, Jaideep. Anybody would like to say anything in the conclusion? But what interesting I have found in most of your presentation is that I am excited to see that most of your units has a open platform, and also it can be configured according to the user's requirement, either by the manufacturer or at the user's end. That is a good thing. And okay, so with this I close. Yes, Jaideep, you would like to say something?
Just I want to say thanks for the comments and all.
So okay, thank you very much, all of you. And now it is the time for closing this session. And thank you very much, and have a nice day.
Thank you, sir.